Hello students, today we are going to see some MCQs based on simple harmonic motion. So now first we should understand what is periodic motion. Any motion which repeats itself after regular interval of time. Very important, the motion appears after a regular interval of time and it goes on repeating, and such type of motion is called as periodic motion. And the time after which the motion is repeated, that particular time is called as periodic time. That time is called as periodic time. And the unit of time as well as periodic time is seconds. They both have the same unit. And dear students, the words which is appearing in bold letters are very important. You should remember this from fill in the blanks as well as MCQ point of view. In periodic motion, if a particle covers the same path back and forth about a mean position, it is said to be vibratory or oscillatory motion. Very important, such motion is called as vibratory or oscillatory motion. Again, the words which are appearing in bold letters are very important. Motions such as the vibratory or the oscillatory motion which I described in the earlier slide. Such motion is bounded. That is, bounded means its displacement on the either side of the mean position is confirmed within well-defined limit. It will not cross that limit, upper limit. It will always be there in that limit. So this slide is important from true or false point of view. As we already saw the displacement of the particle in periodic motion. Now this displacement of the particle executing the oscillatory motion is always expressed in terms of sines or cosines, or even the combination of both are allowed. If you see any equation which contains only the sine term, it is also that equation we can say it is following the SHM. Also, if contains a cosine, then it also means that it is SHM, simple harmonic motion. And if you see any equation which is the combination of both sine and cosine, so for example 2 sine x plus 2 root 2 cos x, these two, when you will get an equation, if you see such equation, then remember students, this is nothing but simple harmonic motion they are executing. So if you are familiar with any of the musical instrument, so you came across with this motion, and that motion which is associated with musical instrument also, and it is nothing but the harmonic motion. One of the most important fact you should remember is all the periodic motions are not necessarily harmonic motion. Very important from true or false point of view. If any body is executing a periodic motion, it is not necessary it is having harmonic motion. But all harmonic motions are periodic motion. It's vice versa. Means, as I already earlier told you, periodic motions may not be necessary that it should be a harmonic motion. But whereas the harmonic motion should be are always per periodic motion, and is possess definite frequency and hence has fixed time period or periodic time. So words which are appearing in bold are very important from fill in the blanks as well as from the true or false point of view. Now example of such motion is periodic motion is motion of earth around the sun. It is periodic but not harmonic. Other few examples are motion of clock pendulum, vibration of a tuning fork, then needles of the sweeping machine, mass and spring system which you perform the practicals in your lab, a bar magnet suspended in a uniform magnetic field are examples of harmonic motion. There are two types of harmonic motion. First is linear simple harmonic motion, and second is angular simple harmonic motion. The difference between these two motions are linear means any motion which is appearing in a straight line, and angular simple harmonic motion means in which angle is involved. So these are the two different type of harmonic motion. One is the linear simple harmonic motion and second is angular simple harmonic motion. Throughout the oscillatory motion, if we consider any oscillatory motion of the particle, then always there exists a restoring force which tries to keep the body back to its original position. and in such manner it goes on oscillating. So here the restoring force is given by F is equal to minus kx. Very important. This equation is important from numerical point of view. They can either give you the value of k or x, and they will ask you to find F, or any of the term is missing and you will ask to find the corresponding term. So remember, F is equal to minus kx means the negative sign always indicate that the displacement always try to come back to its mean position. It always tries to come towards the mean position. And in this process, always remember the total energy of the particle is always conserved. Means there happens there is a chance of interconversion of potential and kinetic energy. So you may see that the potential energy is continuously changing from 0 to certain maximum value, and simultaneously the kinetic energy also changes in the same manner, so that the total energy is the combination of addition of potential and kinetic energy is always remains constant. That is always maintained. Hence, the total energy of the particle is conserved. The particle performing oscillatory motion subjected to the restoring force, which is proportional to, it is always proportional to displacement, and it is always directed towards the mean position. As I already told, the minus sign indicate that it's a displacement. It is always directed towards the mean position. It will try. A restoring force is developed so that it tries to bring back the body to the original position. And here the negative sign F is equal to minus kx, where F is the force, k is the force constant, and x is the displacement. Minus sign indicate that it is always directed towards the mean position, and is called as harmonic oscillator. Any particle which performs such motion, we can say that it is a harmonic oscillator, and the motion performed is called as harmonic motion. Linear simple harmonic motion. The linear simple harmonic motion of a particle is a periodic oscillating motion. As I already told you, if a body is executing linear simple harmonic motion, it will repeat its motion after every regular interval of time. So certain things you should remember. The acceleration of the particle or the restoring force acting on it are always proportional to the displacement. It's important. It's very really important that it is proportional to the displacement from the center of the path. And second important point that you should remember is the acceleration and the restoring force are in the direction opposite to each other. First is proportional, and second is opposite to each other. That is always directed towards the mean position. That negative sign, importance of the negative sign always comes, and that is nothing but the acceleration and the restoring force, they are opposite to each other. This slide is very important from true or false as well as fill in the blank point of view. Now this slide is again very important from numerical point of view, so I just again put the equation so that you can remember this very thoroughly. At this time, the restoring force of acting on any body is given by F is equal to minus kx, where k is constant and also called as force constant. Maybe they can ask you, they will give you the value of F, they will give you the value of x, and they will ask you to find k, that the force constant. Again, this slide is very important from numerical point of view. From Newton's second law of motion, F is equal to mass into acceleration, and we can write acceleration in the form of differential form. So equation become F is equal to m into d2x upon dt square. Again remember the differential equation of simple harmonic motion. It is given by d2x upon dt square plus omega square x is equal to 0. As we already saw the simple harmonic motion, if a particle is executing simple harmonic motion, then it has amplitude. Then what is amplitude? Amplitude is nothing but the maximum displacement of the particle. A particle which is executing simple harmonic motion, then it is having a maximum displacement, the upper limit. So the maximum displacement of the particle is called as amplitude, and in certain book it is represented by the symbol A. There is nothing but A is the official symbol of amplitude. No, it may vary with the textbooks. So in the book which I am referring, here it is given as small a. So velocity of the particle which is executing simple harmonic motion is given by the mathematical formula V is equal to dx upon dt is equal to omega under root a square minus x square. Remember students, this slide is very important from numerical point of view. Now the displacement of the particle at any instant means any instant of time, is given by x is equal to a sine omega t plus phi. This is the displacement of particle. Remember this equation thoroughly. As the time changes, sine omega t plus phi, it swings between +1 and -1. Very important, the maximum value of sine omega t plus phi is equal to 1 and the lowest value will be -1. And the corresponding displacement of x will also vary from +a to -a. Remember these values from multiple choice point of view. Very important line. Displacement repeat itself after regular interval of time, as I already told you, and that is nothing but 2 pi by omega. They can change this question number of way, but remember the time period, the displacement repeat itself is given by 2 pi by omega. And this omega can also be written as under root of k by m. So when we write equation in terms of periodic time, then it is given by t is equal to 2 pi by omega is equal to 2 pi under root m upon k. There is a displacement. We can find the velocity of the particle. So velocity is defined as time rate of change of displacement. V is equal to dx upon dt. In the previous equation, as we saw, x is equal to a sine omega t plus phi. So in that, just to do the differentiation, and you will get v is equal to a omega sine omega t plus pi by 2. As sine omega t plus phi is equal to x upon a, cos omega t plus phi is equal to under root 1 minus x square upon a square. Just substituting back in our equation, v is equal to a omega under root 1 minus x square upon a square. If you further solve, we will arrive to the equation v is equal to omega under root a square minus x square. So velocity, you remember this, either they can give you the value of omega, a and x, they will ask you to find v, or they can interchange, but numerical point of view as well as fill in the blanks point of view, this slide is very important. Also, the instantaneous velocity of the particle performing simple harmonic motion leads to the displacement by pi by 2 radian. Remember always, the velocity of the particle performing simple harmonic motion leads the displacement. So, and how much it is leading the displacement? By pi by 2 factor, pi by 2 radian, and it is maximum at the mean position. It is always maximum at the mean position. We determined velocity. In the same manner, acceleration can also be determined. Acceleration of a simple harmonic motion is defined as time rate of change of velocity. So we already have x is equal to a sine omega t plus phi. So double differentiation of this equation, we will get minus omega square x. Very important, acceleration is given by minus omega square x. They can give you the value of omega and x. They will ask you to find the acceleration. So remember this mathematical statement from numerical point of view. The acceleration of the oscillator is maximum when sine omega t plus phi, as I already told you, sine omega t plus phi, the value of this is always varying between +1 and -1. So it is maximum when it is plus. So sine omega t plus phi is equal to 1 is the acceleration when maximum acceleration, and that value is nothing but omega square into amplitude. The instantaneous velocity of the particle performing simple harmonic motion leads the displacement by pi by 2 radian. Remember this term, leads the displacement. Velocity is leads the displacement by pi by 2, and it is maximum at mean position. Always remember it is maximum at mean position, and V max is given by A into omega. The acceleration of simple harmonic motion leads the velocity by pi by 2 radian in phase. Very important. Now acceleration and velocity. So acceleration leads the velocity by pi by 2 radian in phase, and as if we compare between acceleration and displacement, then the acceleration leads the displacement by pi radian. Earlier it was pi by 2, now here it comes pi radian, means this acceleration and displacement, they are opposite to each other, means they are anti-phase to each other, they are out of phase to each other. Which terms are out of phase with each other? That is the acceleration and the displacement, they are out of phase with each other. Another term for out of phase is the anti-phase. Now again this slide is very important from numerical point of view. Kinetic energy max is given by half m omega square a square, and here x is equal to 0, that you should remember. Acceleration is given by d2x upon dt square. When we substitute the value of x and differentiation, we will obtain minus omega square x. The negative sign indicates that acceleration is always directed towards the mean position. Now restoring force is given by m omega square x is nothing but k into x, where k is force constant or proportionality or stiffness. Remember this from numerical point of view as well as from fill in the blanks point of view. Potential energy is given by half m omega square a square. At this position x is equal to a. Remember this from numerical point of view. And now the total energy is given by half m omega square a square. But we know that k is nothing but m omega square. If we substitute, we will get the total energy is equal to half k a square. Again, this slide is very important from numerical point of view. There are chances that they can ask numerical based on this slide. Now we will see resultant of two simple harmonic motion where the frequency are in the ratio 1:1. So I will not go into the derivation. This is nothing but the Lissajous figure derivation. You will arrive to equation x square upon a square plus y square upon b square minus 2xy upon ab cos phi is equal to sin square phi. This equation is gives the expression for resultant motion of two simple harmonic motion, and important, these two simple harmonic motion, they are right angle to each other and represent the equation of an ellipse where major and minor axes are inclined to coordinate axis. This ellipse can be inscribed in a rectangle whose sides are equal to 2a and 2b. Remember, each and every word is very important from fill in the blank point of view. Now we saw the final expression for resultant of two simple harmonic motion. They are right angle to each other and also the frequency are in the ratio 1:1. So let us see some of the cases from case 1. When phi is equal to 0, so cos phi will be equal to 1 and sin phi will be equal to 0. When you substitute in that, you will get x square upon a square plus y square upon b square is minus 2xy upon ab is equal to 0. It is a pair of coincident straight line passing through the origin, and it passes in the first and third quadrant as you can see in the figure. Remember this, when phi is equal to 0, then it represents a pair of coincident straight line passing from first and third quadrant, and also the angle is given by tan inverse b by a. When phi is equal to phi by 4, cos phi and sin phi will be equal to 1 upon root 2, and the equation becomes x square upon a square plus y square upon b square minus root 2 xy upon ab is equal to 1 by 2. It represents an oblique ellipse lying in the first and third quadrant. Case 3. When phi is equal to pi by 2, cos pi by 2 is equal to 0 and sin pi by 2 is equal to 1, then that expression reduces to x square upon a square plus y square upon b square is equal to 1. This represents a symmetric ellipse whose major and minor axes coincide with the coordinate axis as shown in the figure. You can see. If a equal to b, then the resultant vibration is circular, means x square plus y square is equal to a square. That means it represents a circle of radius a and is represented by x square plus y square is equal to a square. When phi is equal to 3 pi by 4, means cos 3 pi by 4 is nothing but minus 1 upon root 2 and sin 3 pi by 4 is equal to 1 upon root 2. So our equation reduces to x square upon a square plus y square upon b square plus root 2 xy upon ab is equal to 1 by 2. This again represents an oblique ellipse lying in the second and fourth quadrant. Very important. Till now it was the first and third quadrant. Now the ellipse tilted to second and fourth quadrant. When phi is equal to pi, cos pi is equal to -1, as we already know, and sin pi is equal to 0, this equation reduces to x square upon a square plus y square upon b square plus 2xy upon ab is equal to 0. This is nothing but x upon a plus y upon b, the whole square is equal to 0. Again, it represents a pair of coincident straight line. Now it is passing through second and fourth quadrant through the origin. Very important, this you should remember. And also the angle is given by theta is equal to tan inverse b by minus b by a. Case 6, when phi lies between pi and 2 pi, very important, when phi lies between pi and 2 pi, the whole cycle from case 1 to case 6 goes on repeat, but in a reverse order. It will repeat in a reverse order. You will get the same equation, but in a reverse order. As I already told you, Lissajous figure in the lab. So quickly we will see what is Lissajous figures. When a particle is acted upon by simultaneously by two simple harmonic motion, very important. In order to obtain Lissajous figure on the screen of CRO, you need two simple harmonic motion, and they should be right angle to each other. Then the path traced out by the particle is called as Lissajous figures. So the nature of the resultant path or the curve traced out depend on, first on the amplitude, second on the period or the frequencies, and the third is the phase difference between the two vibrations. You should remember these 3 points are very important before the formation of Lissajous figure. First is the amplitudes, second is the period or the frequency, and the third is the phase difference between the two vibrations determine what kind of a curve you are going to obtain. Now we will see the resultant of two simple harmonics where the frequency are in the ratio of 1:2. So in that, in spite of one ellipse, we will get two ellipses. When phi is equal to 0, we have x is equal to a sin omega t, y is equal to b sin 2 omega t. So this y is equal to, can be written as 2b sin omega t cos omega t. So y by b is equal to 2 sin omega t cos omega t. And after substituting, we will get equation 4x square upon a square, x square upon a square minus 1 plus y square upon b square equal to 0. This is a resultant which represent a figure of infinity, as you can see from the figure. It represent a infinity. When phi is equal to pi by 2, x is equal to a sin omega t, and from this we can get x upon a is equal to sin omega t, and y is equal to b sin omega t plus phi by 2, so that is b cos 2 omega t. After solving this, we will get x square is equal to minus a square upon 2b y minus b. This is the equation of a parabola symmetric about the y-axis having the vertex of 0, b. Let's see some numericals. A body executing simple harmonic motion has velocity 80 cm per second and 60 cm per second when displacement are 3 cm and 4 cm respectively. Calculate the amplitude of vibration and the time taken to travel 2.5 cm from positive extremity of the oscillation. Here first you should check what are the units. So in this numerical, they gave all the units are in CGS system, so there is no need to conversion. No need for conversion. Now at x1 is equal to 3 centimeter, they gave velocity v1 is equal to 80 centimeter per second, and at x2 is equal to 4 centimeter, velocity v2 is equal to 60 centimeter per second. We already know the velocity equation, mathematical equation for velocity. V is equal to omega under root a square minus x square. So for both the velocities we will write, because omega is same. So when we will divide that two equation, we will get v1 upon v2 is equal to under root a square minus x1 square divided by under root a2 square a square minus x2 square. Now because we need to find the amplitude is unknown, so 80 upon 60 is equal to under root a square minus 9 under root a square minus 16. So squaring both sides and solving, when you solve, you will get a is equal to 5 centimeter. Also now we are interested in finding the periodic time. As we already got from the previous slide, amplitude is equal to 5 centimeter, x1 is equal to 3 centimeter, v1 is equal to 80 centimeter. We get, when we substitute in our equation omega, we will get first omega is equal to 20 radian per second. Now time to move from mean to positive extreme is given by phi is equal to 5 omega t. X is equal to a sin omega t. In that equation we will substitute and we will get phi is equal to 5 omega t. Omega t is equal to, we already know, pi by 2. Periodic time is equal to pi by 2. So t is equal to pi upon 40 seconds, because the t is equal to pi by 2 into omega. The time to move from mean to 2.5 centimeter from extremity, that is 5 minus 2.5, that is 2.5 centimeter from the mean. So we will back substitute. So 2.5 is equal to 5 sine omega t, that is 20 into t dash, that is the new time. Therefore when you solve, you will get t prime is equal to pi by 120 second. And time to travel 2.5 centimeter from extremity, that is t minus t prime is equal to t by pi by 40 minus pi by 120, which will give us 0.052 second. A particle of mass 5 kg lies in a potential field. V is equal to 8x square plus 200 joule per kg. Calculate its time period. So velocity is given, potential field is given. It's not velocity, it is the potential field is given. V is equal to 8x square plus 200 joule per kg. So potential energy, it is denoted by U, and it is given by U is equal to M into V. So V is already, we know, 8x square plus 200. So potential energy is given by U is equal to M into 8x square plus 200. Now to find the restoring force, we know that restoring force is equal to minus du upon dx. Just substitute the value of u. So minus d dx of 8m square plus 200 m. So we will get minus 16 mx is equal to minus kx. We know that f is directly proportional to minus x. F is equal to minus kx. We are already familiar with that equation. So motion of the simple harmonic motion, angular frequency omega is equal to under root. We know that k under root k by m. Substitute the value of k from the above equation. We will get k is equal to 16m divided by m. So nothing but under root of 16, which is equal to 4. That is the angular frequency omega is equal to 4. And so periodic time, we know that t is equal to 2 pi by omega. In place of omega, just substitute the value of 4. We get 2 pi by 4 is equal to 1.57, and the unit is second. Calculate the displacement to amplitude ratio for a simple harmonic motion when kinetic energy is 90% of the total energy. Here, we are interested in finding the displacement to amplitude ratio. And it is given that kinetic energy is 90% of the total energy. We know that total energy is the sum of kinetic energy and potential energy. If kinetic energy is 90%, means potential energy will always be equal to 10% of the total energy. So let us solve this problem. If m is the mass of the particle executing simple harmonic motion, a is the amplitude and omega is the angular velocity, then total energy, we know that the mathematical statement is given by E is equal to half m omega square a square. If x is the displacement, then when kinetic energy is 90% of total energy, means potential energy will be equal to total energy minus kinetic energy, that will be equal to 10% of the total energy. So potential energy is given by half m omega square x square. Just you need to write the equation. Potential energy, mathematical statement is half m omega square x square, and total energy, that is half m omega square a square. So half get cancelled, m get cancels, omega square also get cancels. We are remaining with a square upon x square will be equal to 0.1. So when we will solve, taking square root of both sides, we will get a by x is equal to 0.316. Now next numerical, moving towards next numerical. Show that if the displacement of a moving point of any time is given by an equation of the form x is equal to a cos omega t plus b sin omega t, the motion is simple harmonic. If a is equal to 3, b is equal to 4 and omega is equal to 2, determine the period, amplitude, maximum velocity and maximum acceleration of the motion. So this problem is divided into 4 parts. So in the exam, they can ask you any one part based on this numerical. There are chances. So what they gave you, the displacement of the particle is given by x is equal to a cos omega t plus b sin omega t. As I already told you, a particle which is executing simple harmonic motion, the displacement is expressed either in terms of sine terms or in terms of cos terms or it may be the combination of sine and cos. So when you see this type of equation, you just remember this is nothing but simple harmonic motion. But though they are asking us to show that, so we will move to prove that this equation is representing simple harmonic motion. So the displacement is given by x is equal to a cos omega t plus b sin omega t. So we are interested in finding the velocity. We know that the rate of change of velocity is nothing but rate of change of displacement is the velocity. So we will differentiate the above equation with respect to time. So we obtain b is equal to minus a omega sin omega t plus b omega cos omega t. Again differentiating velocity with respect to time, we will get the acceleration, that is nothing but when you solve you will get minus omega square x. Yes, this equation shows that it is executing a simple harmonic motion. Now the particle execute a simple harmonic motion. Now we are interested in finding the amplitude. So amplitude is nothing but under root a square plus b square. So first they gave amplitude a is equal to 3, and for the second one they gave you b. So when you substitute, we will get under root 3 square plus 4 square, which is nothing but under root of 25, that is equal to 5 centimeter. Now we are interested in finding the time period of the particle. We know that t is equal to 2 pi by omega. Just substitute the value of omega from the above equation. We will get 2 into 3.14 divided by 2 is equal to 3.14 second. And now the maximum velocity of the particle is given by, we are already familiar with the maximum velocity is given by omega a. Now that is nothing but 2 into 5, which will give you 10 centimeter per second. And the maximum acceleration is nothing but omega square into a, that is 2 square into 5 is nothing but 20 centimeter per second square. So this numerical is very important. They can cut short and they will ask you only to find any one term out of the 4 parameters they are asking to find. So last few more MCQs. Which of the following variable has 0 value at the extreme position in simple harmonic motion? We know that in simple harmonic motion there are 2 extreme points and there is a mean position. Now they are asking which variable is having 0 value. So the velocity, or they can term as speed, is having 0 value at the extreme position in simple harmonic motion. The correct answer is velocity or speed. What is the amplitude of the motion? They gave you displacement equation x is equal to 2 sine 2t plus 4 sine square t. So we are interested in finding the amplitude. They gave answer as 2 root 2m, 4m, 2m, and the last is the given equation is not a simple harmonic motion, but this is a simple harmonic motion. As we know, sine or cosine or combination these two is nothing but simple harmonic motion. So they gave us x is equal to 2 sine 2t plus 4 sine square t. When we will solve, so we will get 2 sine 2t plus 2, 1 minus cos 2t. We are making it in terms of 2t. Theta is equal to 2t. So 2 sine 2t minus 2 cos 2t plus 2. This is nothing but 2 root 2 sine 2t minus pi by 4 plus 2. So the amplitude is 2 root 2 m. In a simple harmonic motion, the time taken to go from mean position to a by 2 is same as that of a by 2 to a. True or false? Here a is the amplitude of motion and the answer is B. False, because in simple harmonic motion the speed is maximum at the mean position and goes on decreasing to the extreme position. So here they gave the position from mean to a by 2, means mean means 0 to a by 2, and from a by 2 to a, it is not coming back to 0. So it will be different. So that's why the above statement is false. In simple harmonic motion, what is the phase difference between velocity and acceleration? As I already told you, it is pi by 2. The periodic time is given by option A omega by 2 pi, option B 2 pi by omega, option C 2 pi into omega, and option D pi by omega. The answer is 2 pi by omega. The velocity of the particle moving with simple harmonic motion is dash at the mean position. Always remember, at the mean position the velocity is maximum and at the extreme position it is 0. So the correct answer is C, maximum. The maximum acceleration of a particle moving with simple harmonic motion is given by option A omega, option B omega dot r, option C omega square into r, and option D is omega square into divided by r. The correct answer is omega square into r. As I already told you, textbook to textbook, these notations will vary, but always remember omega square into the amplitude. Here they represented amplitude by r. A rigid body is suspended vertically and it oscillates with a small amplitude under the action of a force of gravity. The body is known as we already performed this experiment in our lab, and we know this is not a simple pendulum, this is not a torsional pendulum, it is compound pendulum, and it is not a seconds pendulum. The correct answer is compound pendulum. A body is said to vibrate with simple harmonic motion if its acceleration is proportional to the distance from the mean position. Whether the statement is true or false. The answer is true. A body is said to move with simple harmonic motion if it satisfies the two conditions as I already told you. Its acceleration is always directed towards the center, that is the mean position, and its acceleration is proportional to the distance from the point. The maximum displacement of a body from its mean position is called amplitude. Whether it is a true or false. Yes, that is correct. It's true. The time taken for one complete revolution of a particle is called as periodic time, as I already told you. And the maximum displacement of the body from the mean position is called as amplitude. Frequency of vibration is usually expressed in terms of number of cycles per hour, number of cycles per minute, number of cycles per second. None of the above answer is correct. So the correct answer is number of cycles per second. Very important, it is the second. So number of cycles per second means option C is correct. The amplitude of vibration is always dash the radius of the circle. So it is always equal to the radius of the circle. It is not less than, it is not greater than, and it is not the option 4. The correct answer is equal to the radius of the circle. So correct answer option is A. The time taken by a particle for one complete oscillation is known as periodic time. Whether it is a true statement or a false statement, it is true statement. The time taken for one complete revolution of a particle is called as periodic time, and the maximum displacement of the body from the mean position is called as amplitude, which I already told you. The periodic time is given by omega by 2 pi, or option B 2 pi by omega, option C omega into 2 pi, or option D pi by omega. The correct answer is B, option 2 pi by omega. Very conceptual question. When a body moves with simple harmonic motion, the product of periodic time and frequency is equal to, whether it is option A 0, option B 1, option C pi by 2, or option D pi. And the correct answer is, it is always equal to 1. The correct answer is B, 1. The acceleration of the particle moving with simple harmonic motion is dash at the mean position. Here they are talking about the acceleration. So acceleration of a body is 0 at the mean position. It is 0 at the mean position and maximum at the extreme points. So the correct answer is A, that is 0. The maximum velocity of the particle moving with simple harmonic motion is given by omega, or omega into amplitude r, or omega square into r, or omega by r. And the correct answer is omega into r. When a particle moves around the circumference of a circle of radius r with omega radian per second, and its maximum acceleration is omega square into r, where r is the radius they are given, means it is nothing but the amplitude. So the correct answer is true. The statement is true. So A is the option A is correct. The acceleration of the body moving with simple harmonic motion at any instant is always given by omega square into the amplitude. By how much angle in degrees does the velocity leads the displacement? Here they are giving velocity is leading the displacement in a body undergoing simple harmonic motion, and we already know it is pi by 2, that is 90 degree. For a body undergoing simple harmonic motion, the acceleration is always in a direction of displacement. Whether the statement is true or false, the answer is false. For a body undergoing simple harmonic motion, the acceleration is always in the opposite direction of the displacement. It is not in always in the same direction. So it, as I already told you, there always appears a negative sign. So the negative sign is always there. They are not in same direction. They are in opposite direction to each other. Which of the following is the correct differential equation of the simple harmonic motion? Option A, d2x upon dt square plus omega square x is equal to 0. Option B, d2x upon dt square minus omega square x is equal to 0. Option C, d2x upon dt plus omega square x is equal to 0. Or d2x upon dt minus omega square x is equal to 0. The correct answer is option A, that is d2x upon dt square plus omega square x is equal to 0. For a body undergoing simple harmonic motion, the acceleration is maximum at the extreme, whether it is a true statement or a false statement, and the correct answer is true statement. Acceleration is always maximum at the extreme. Which of the following is the solution of differential equation or the simple harmonic motion? Option A, x is equal to a cos omega t plus b sin omega t. B, x is equal to a plus b cos omega t. Option C, x is equal to a plus b sin omega t. Or option D, x is equal to a tan omega t plus b sin omega t. As I already told you in the beginning of this video, that for the differential equation can either be sine terms only or cos terms only or combination of sine and cos, but there is no I never told that the amplitude will be combination of certain numbers. So the correct answer is x is equal to a cos omega t plus b sin omega t is the correct option. Or if you want to cross check, just to do the differentiation with respect to time. So dx upon dt will give you a sin omega t sin omega t. d2x upon dt square is equal to, you will get certain things, and when you back substitute, whether you obtain d2x upon dt square plus omega square is equal to 0. If you get 0, then this is the solution. So remember, x is equal to a cos omega t plus b sin omega t is the solution of the differential equation. Thank you.